Hello math students. Today's video is going to cover the topic called compound inequalities, and you should have this worksheet in front of you to take notes as I guide you through it. I'm just going to start here with this first portion of the worksheet, just kind of reading out loud to you as you read along with me. First, it starts with the definition of a compound inequality. So it says, a compound inequality will contain one of these words, and the words are, actually let me grab a highlighter here. The words are and, which is my favorite, and then down here later on in the worksheet, the other word is or. So in any compound inequality, you're going to have either the word and or, and these words are going to hook up two different inequalities, hence the word compound. So a compound inequality is two inequalities at the same time connected by the word and or the word or. Okay, so with and, let's read about this. It says compound inequalities with the word and are called conjunctions. A conjunction is true only if both of its statements are true. So that's important. When it's an and statement, both of your inequalities have to be true at the same time. So check out example 1. Now I use this because my son plays for Mannheim Central. I didn't have the actual stats for CV, and I didn't know who to contact when I wrote this problem, so I used what I knew from my son's football league. So here's what it says. To play football for the Mannheim Central Athletic Association, players must be between the ages of 9 and 14. Write a compound inequality to represent the ages of the players in the MAA. That just stands for Mannheim Athletic Association. Then graph the solution. Okay, so this is a compound inequality because players have to be between the ages of 9 and, there's the word, 14. Okay, so this is pretty easy. If we just let A represent the ages of the Mannheim Central Athletic Association players, then I can really easily write two inequalities. The first one is going to be that A, the ages of my players must be greater than or equal to 9. So this is going to take care of all my ages equal to 9 and higher. But that would be a little crazy because if we went to the number line and we graphed that, we would put a solid dot at 9 and show all solutions greater than or equal to 9. Now, we darn well know we don't want my son who's 11 playing with 20-year-olds. So that's where my and statement is going to come in. So, and at the same time that my players must be greater than or equal to 9, they also have to be less than or equal to 14 years old. So there's my and. So if I draw this part of the graph, I go to 14, I hook up a solid dot because I'm including 14-year-olds, and I shade lower. So you can kind of see where the two merge on each other. Where they overlap is going to be my final answer, and you can kind of see right here at the 9 and the 14 is where one leaves off and the other picks up. So my final graph is going to be solid dot on 9, solid dot on 14, and I'm going to shade everywhere in between because this is where both inequalities are true at the same time. 9-year-olds to 14-year-olds inclusive, that's who can play in this athletic association. Okay, now this is where it gets interesting. But if you understand this from the jump, then you will always know it and we'll never have to go over it again. So I'm going to take my time explaining this next part. When you have the word and connecting two inequalities, I call this fancy. Now, I'm well aware that the word fancy does not have a D in it. But for the purposes of remembering it in math class, fancy just became fancy. So ands, which you can see that word right here, can be written fancy. And what do I mean by that? Well, you take the right side here of your inequality. Look at it. A is less than or equal to 14. And you click and drag it over here under this word. So I'm just going to write ages are less than or equal to 14. Simple. Then you take the left side, right here, and you do a 180 with it. So you're going to take the 9 that's on the right, put it on the left. You're going to take the A that's on the left, and you're going to slide it over to the right, and you're going to take this symbol and flip it 180. So these two mean the same thing. A is greater than or equal to 9, or 9 is less than or equal to A. Those mean the same thing. Now, if you click and drag this, pull it over here and set it right there, you see, here's the A, just copy the rest down, and there's 9 is less than or equal to A. So, why don't I have my light on? That's better. Okay, so this means the same thing as this, but this is considered condensed. We took the word and out. We've got both inequalities wrapped up into one statement. What's cool about it is you can see that A actually physically sits between 9 and 14, like the ages are between 9 and 14. So that's pretty cool. It like looks like what it sounds like in the words. And if you cover up, like if you take your finger and just cover up, like your ages have to be under 14. And you see this freaks students out because the 9's on the wrong side. But if you take this and flip it over, you're right back here to A is greater than or equal to 9. So this is fancy, and you can see the shading between 9 and 14. Okay, so that's your example of the and. The or is way easier. Ors are not complicated at all. They're just, I'll read it to you here. Compound inequalities with the word or are called disjunctions. A disjunction is true if one or the other or both statements are true. So this doesn't have to be everything at once. It doesn't have to have everything happening simultaneously. It just needs one true statement. So here's the deal. Example 2 says solve and graph the solution. So you have 4 plus 3x is less than or equal to negative 11, or 4x plus 6 is greater than 18. So we're just going to solve these separately. We're going to solve this one, then we're going to solve this one, and we're going to graph the solution, and we're going to be done. So we're experts at this. We'll go through this pretty quickly. For this guy, you can draw your line here to keep balance. I'm going to subtract 4 from both sides. This is going to give me 3x is less than or equal to negative 15. I'm going to divide by 3, both sides. So x is going to be less than or equal to negative 5. Done. Graph that. Simple. All numbers less than or equal to negative 5 means all numbers from negative 5 on down to the left. There are all my numbers less than or equal to negative 5. On the other side of the or statement, I'm going to subtract 6 from both sides. So 4x is greater than 12. And I'm going to divide by 4. So x is greater than 3. So or comes down. X is greater than 3 means I've got to show all numbers bigger than 3. Not including 3, but bigger than 3, which is why I put this open dot there. So these two areas represent all the numbers that match this statement or this statement. And the little trick I always give my students is this. If it's an and, ands go in, meaning when it's an and, the shading joins, it goes inward. But ors go out, like the oars of a boat. Think about if you row a boat with oars, your elbows go out, so the oars go out and the ands go in. Okay, 1 to go on the back. Example 3 says solve and graph the solution, and look at this. It says, if I read it, it says negative 8 is less than 2x minus 6, which is less than 4. Now the first question we got to figure out is this an and or an or? Well, it looks like it's written fancy because there's no word. There's no word. I don't see an and or an or, but I definitely see that fancy form. So this is an and. By the way, if it's an or, the word or will have to be there. And is the only one that can be written without the word. Okay, so to solve it, it's pretty cool. All you do is draw your line here, draw your line here. And what I like to do is cover this up and just look at it like that. 2x minus 6 is less than 4. What would you do to solve it? Well, hopefully you're thinking you would add 6 to both sides, and that's exactly what you do. But guess what? You also add it over here. So it looks like this, plus 6, plus 6, plus 6, like a 3-for-1 special. So negative 8 plus 6 is negative 2. Bring your less than down. 2x, cross those out. Bring your less than down. 4 plus 6 is 10. Cover this up. What would you do next? 2x is less than 10. Well, hopefully you're thinking you divide by 2. And that's what you do, but you do it here, here, and here. So now you have negative 1 less than x, which is less than 5. There's my answer. Now, let's pull this down here. So if x is in the middle with a negative 1 and a 5, can we turn this back into an and statement? Yeah, we can. It's simple. Just take this side right here, x is less than 5, and take this part, flip it, pull the x over here, pull the negative 1 over there, flip this 180, and you've got x is greater than negative 1. So we need to shade numbers bigger than negative 1 and numbers less than 5. Bigger than negative 1 and less than 5. Bigger than negative 1, bigger than negative 1 and less than 5. Bigger than negative 1 and less than 5. Bigger than negative 1 and less than 5. The ands go in. You can see it. I'm shading numbers between negative 1 and 5. Non-inclusive, so my dots are open. And this just means I can pick anything in here and put it in for x in my original problem, and it will be true. If you pick, I don't know, pick 3, that's in there. If you stick 3 in for x up here, you're going to have negative 8 is less than 2 times 3 minus 6, which is less than 4. And then just see if it works. Negative 8 less than 6 minus 6 is 0, which is less than 4. So is 0 less than 4? Yes. Is 0 bigger than negative 8? Yes. So it works, and it should. All right, cool. Compound inequalities. Thanks for watching.